So, hello everybody. Thanks for joining our next talk, and I'm very glad to have Dominik Matula here. He's a data scientist at Profinit, a consultancy from Czech Republic, and he will talk about the topic of installment detector, revealing clients' behavior from transactional data. And so Dominik will also actually talk about the use case of analyzing transactional data from a major European bank and how you can use the graph relationship. So the graph created by the actual transactions between clients, as well as the actual transaction classification and how this knowledge can be used to classify clients. So Dominik, thanks for joining us. Thanks for giving the talk. I'm already looking very much forward to it, and the stage is yours.
Thank you. Hello guys, welcome to this webinar. So Mario already said almost everything, so let's move on to the first slide. As Mario said, my name is Dominik Matula. I am senior data scientist. Our company, Profinit, is one of the top IT companies in Czech Republic, and our customers are primarily banks and other financial institutions. Therefore, we focus our data science to their sector. We are focused our data science to revealing, to mining financial transactions. And that will be topic of this webinar. I'd like also to mention that I'm a member of two research groups with two Czech universities, with guys from Charles University in Prague. We are doing research on so-called pseudo-social networks. These are social networks made exclusively from financial transactions. And therefore, from these networks, bank can do some predictions. And in the second research group with Czech Technical University in Prague, we are using machine learning techniques to detect fraud. But that's not the topic of this webinar, so let's move on. Before I start with the actual topic, let me mention there is a Slido session open over here. So if you have any questions during the talk, please don't hesitate to ask. I'll do my best to answer your questions. And now let's dive into data. We will start with a use case. Imagine you are part of a big bank. You have like hundreds of thousands or even millions of clients. And to fulfill their needs, and of course to make some profit, you offer them various products. It's well known that some of products are more profitable, some of them are less profitable. And one of the most profitable products are consumer loans. So imagine idle world. All your clients has a loan from you, your profit is maximized, your boss is happy, everything's fine. Idle world. Unfortunately, in the real world, it's far from true. There are a lot of your competitors all around with their own consumer loan products. So it happens the most of your clients already has a loan elsewhere, and they are not responsive for your offer. Your boss is not so happy, your profit is not so awesome, and the boss comes to your office and asks you, hey, Dominik, we need to do something. We need to find those clients to be able to do precise marketing. So how can you help him? How do you find those clients? Of course, it's the topic of the installment detector. But before we reveal its secrets, I'll take a step toward the benefits of such a knowledge which clients has a loan elsewhere. I've already mentioned profit maximization. Let's strive forward. Nothing to discuss. But this knowledge could be beneficial also for your clients. How it's possible? Just think about your competitors. They are terrible. They have terrible conditions. They have high interest rates. They have fees, etc. So if your clients consolidate their debts to you, they will save their own money. So that's a win-win strategy, at least for you and your clients. The third benefit I've mentioned over here is advanced risk scoring. Once you are able to track, for example, peer-to-peer loans, you will know your client's debts precisely and you will be able to do advanced risk scoring. And last point over here, but definitely not the least, is the client's loyalty. The more products client has from you, the more he or she is loyal to you. Okay, I'll stop business talk now and really dive into data. So, as we already mentioned, me and Mario, the focus is on the transactional table. Here is just a toy example with just 6 columns over here: client, receiver, date, amount, symbol, transactional node. Nothing big. The question is, which column should I use if I want to detect loan payments? Which columns are most useful? Actually, that's a question for you. So at last, I'd like to ask you to open Slido and try to guess which columns are the most useful. I'll switch to Slido over here and start the poll and give you several seconds to make a guess. So we will see. Nobody's there. Okay. Several more seconds. Maybe something's wrong with Slido.
Can you just share it, the Slido link to the in the chat?
Sorry, that's quite simple. Simple Slido and hashtag Profinit, which is the name of our company. I haven't been very original. Okay, definitely not. At least one guy responds, so thank you. And we will move on because the time's running. I have good news for you. All of these columns are relevant. Each of them in different way. The most conventional approach is to use receiver column to build some blacklist or whitelist of receivers, of course. But you can do some amount value filtering, you check some symbols presence, and of course, do some transactional mining. That's all of these ways are possible. Unfortunately, they have their downsides. The blacklist and whitelist will outdate like constantly. The amount filtering is imprecise, and these two columns, symbol and node, both are optional. Therefore, they will be confusing and sparse. All these problems is present in the next example over here. Imagine your client Carlo over here made a transaction to the receiver B. Unfortunately, this account is not in your blacklist because of outdating. Okay, so he paid like 21, 22 euros with this symbol, and he mentioned a mobile. And the question is he paying his bills to, for example, T-Mobile Austria or Deutsche Telekom, etc.? Or has he bought an iPhone and now he's paying a loan payment? Who knows? So again, I promise this is the last time I'll try to Slido over here. Oh, other guys also answered, thank you. So let's try another question. Do you think Carol over here made a loan payment? Or is he paying his bills? Who knows? It's just guessing. And once we have some answer over here, I will reveal how can you guess this with more probability, with better probability. Okay, thank you for your answers, and let's get back to the example over here. And this is the first key concept behind Instalment Detector and other R models. We are not using just a single bit of information, single transactions, because it's usually uninformative. The know-how is to use a context. Okay, what's the context? It depends. We will touch during this presentation several contexts, but in this case, let's use a context called relation. Relation meaning all transactions coming from one client to one account, either internal or external. Okay? All transactions coming from one client to one receiver is called relation. And as you can see, there's some stability in amount, some same stability in a symbol, and Kara already mentioned a loan payment over here. Therefore, with high probability, you can guess that this transaction is also a loan payment. Okay, so this is the first use context, not just single bit of information. It will enable you much advanced feature engineering, like time series patterns and stability checking, etc. Okay, so this is just a touch of feature engineering, and we will move to machine learning. Because you gain some feature, super duper features, but your boss typically needs results over here. How can you reach these results with your super duper features? Okay, modern, very popular way is to use some black box solution like neural networks. I love them. The problem is their interpretability or lack of interpretability. And this problem, especially in financial sector. So you can use other extreme way, some old but gold model like regression or decision tree. They are great, of course, but they are powerless, especially comparing to black box solutions. So in our installment detector, we are using something called Bayesian networks. I can't see you guys, but in my experience, only a fraction of audience typically knows what Bayesian network is. So let me devote next slide to little intro to Bayesian models. You already have these super duper features over here. To be able to use Bayesian model, you need just two simple things: some prior belief, prior odds, prior probability. This is the same. That the relation is a loan payment relation. It's just something you get from data, from training set. And for each feature over here, you will calculate adjustment factor. Okay, what's the adjustment factor? That's again really easy to get. That's just a fraction compound from number of cases with a feature to a number of non-cases with a feature. Something you will calculate, and once you get this table and this prior belief, you will start modeling. This is a naive example of naive Bayes classifier. I don't know if you are using this, but this is some model which is definitely in your email's spam filter, which just classifies your inbox. How does it work? And how does it work in our context? It's simple. Okay, let's start with two pieces. We have from previous slide, the prior belief over here or over here, and the table of adjustment factors. And then under certain assumptions, you will create this equation over here. For each feature, you will add this factor to the equation. And finally, you do some just high school multiplication, and you will realize that the posterior probability or final probability is 86%. Okay, this was just a toy example. How does it work? But I mentioned some strict assumptions. That's why it's called naive. The assumptions are that they are the features are conditionally independent, and this solves the Bayesian network model. You've already seen this over here. This is an example of naive Bayes, of Bayesian network model. But don't worry, you can view this as a bunch of naive Bayes classifiers. Here is one, and here is another one. Still, each circle means a feature. Here is a feature, here is a feature. Each feature is connected to the adjustment factor, but now each feature tells you which way you should take. Why this is important? Let's think about this feature, and let's say this feature checks whether there is a transaction node in your relation. If there is transaction node, you should check whether there is a loan mentioned in the node. But if there is not a transaction node, it doesn't make sense to take the yellow path, and you will instead evaluate other feature. Okay, this was just simplified intro to Bayesian networks to convince you that they are easy to use and, of course, easy to interpret. All these ways you can follow, you can reconstruct the labeling or the posterior probability to pieces and be able to interpret the model results. So this was intro, and let's move on to the installment detector. Our installment detector is multi-layer Bayesian network model. We have already seen a relation layer. To recap, relation means all transactions coming from one client to one receiver. One receiver, one account. But there are other layers. For example, receiver layer. What does it mean? This is a context of all transactions coming from all your clients to the same account. And we will go through an example on next slide, but I'd like to mention other layers like sender layer and counter relation layer, etc. And each of these layers enables you to be adaptable to market changes, as we will see in next slide. So this is an example of receiver layer context. Again, to recap, it means all transactions coming from your clients, all your clients, to your same account, to the same receiver. The question in this example is, N has made this transaction. Is it a loan payment or not? And that we don't have here any clue, but we can use your other clients. They already made transactions and they labeled this receiver with a label loan. Therefore, with high probability, we can guess and also made a loan payment. Great. And a counter relation layer or counter relation context example, over here are two transactions from your client Carlo, and he didn't mention anything over here. So we can look to counter relation context and see that there is there's other way transaction which is mentioning a loan over here. Therefore, again, we can conclude with high probability that those are loan payments. Okay, big disclaimer over here. All examples you've just seen are based on a node. In reality, that's far from true. In reality, we are doing some time series patterns, some symbol checking, some time series pattern on amount, stability checking, etc., etc. And those features are quite time consuming to express, to describe. So for presentation purposes, I've stick with the node examples. End of disclaimer. And let's move to implementation. This model, we've originally implemented like nearly 2 years ago, and we used big data technologies. Wait a minute, you said. You just show that there is just high school math, just high school multiplication. Why do you use just these big data technologies? That's because those features. This is an example of two simplified features, some count distinct over here and regex expression matching over here. The original data warehouse tools, it took like hour or fraction of hour. With big data technologies, we will be able to calculate these features in tens of seconds. And that's important because in the Bayesian network, there were like tens or even more features. So to be able to process all this big data, we need big data technologies. And what about results? When we were discussing the project with business owner, he told us, okay, we have already some in-house solution based primarily on some blacklist and whitelist. If you can boost it by 10%, it would be awesome. So we played clever and we achieved boost almost 100%. So we doubled the number of transactions found. This is the original found by bank, and this is our addition. With such a small conflict, meaning transactions that the bank said that it's not really a loan payment. How it's possible? As I already said, we played clever. Our installment detector and the techniques behind it are able to detect small lending companies and it's not distracted by changes in banking accounts. If you open your Google, you will find like myriads of lending companies. So it's unmaintainable to bring up to date and to keep up to date some blacklist or whitelist. And that's the gray zone where our solution shined. Also, we are able to track indirect installments and peer-to-peer loans. That means loans between family members and friends, etc. Of course, you are interested in performance, and I have to say that all these calculations were based on bank's data under NDA. As I mentioned in the introduction, we are consultancy and we don't own any bank and we don't own any bank's data. We own just the know-how. Therefore, I can be open here, but I can offer you a POC where we can demonstrate our results on your data and measure added value. This is important also because of the second point over here. The performance really depends on the bank's portfolio of clients and depends on the market context. For example, Czech Republic versus Austria versus Germany, it's different. Okay, so that's about the results, and I'll move on to the last slide where I'd like to recap the key concepts which are behind our solution. The first one is use of some model which can be straightforwardly interpretable. In my experience, it's quite important, especially in banking sector or in financial sector. Use Bayesian networks here. The second concept over here are adaptability to market changes. And we achieve this by using multiple layer principle. We replace some hard-coded black box some hard-coded blacklist and whitelist with a complete layer for a receiver context. The third point over here is to be able to do advanced feature engineering. Don't rely on just one piece of information. Usually, it doesn't carry enough information. Look at each transaction in its context, either in the context of relation, in the context of receiver, in the context of country relation, etc. And of course, all these concepts are also applicable elsewhere. They are not unique to the context of installment finding. So you can build other detectors once you have this model or this kind of model. So this was last slide. Thank you for your attention. Thank you for your time. And I'll skip to the slide 2. So if you have any question, we have several minutes to go. So I'm here and I'll do my best to answer your questions. Thank you.
So thank you, Dominik, again for your talk. Again, if you have any more questions, please, you can also use the Q&A button on Zoom. So I just noted a few ones. Maybe, Dominik, you could, so regarding the installment detector for the bank, what is the exact use or business case to detect loan payments? So what is the bank then doing with those kinds of clients?
Okay. There are several use cases. Banks are usually using this. And I hope I don't forget anything, but some of the most straightforward use case is to know your clients by heart, to find their debts, to do precise risk scoring, more precise risk scoring, because you are now able to detect like peer-to-peer loans and other specialties. it's also this especially important nowadays when fintech companies are enabling and spreading peer-to-peer loans to the mass to the clients. So this is
the bank would use it for risk scoring.
Risk scoring. This is one part. But other interesting part is marketing. Once you are able to detect that the client's going to send money to pay his loan, you can display him in information. Hey, we think you are going to pay a loan. Please consolidate to us. We will give you better conditions, and you will save your money. So that's some interactive online use of this knowledge.
Okay, and have you also considered maybe using this kind of technique for fraud detection, or have you used it?
We don't. We have built some other model for fraud detection. This is it. We don't use it for fraud detection yet.
Okay, but would you consider it, or are you using some kind of
the problem with the fraud detection is that's quite rare. It's really rare to train any machine learning model to detect fraud. It's really complicated. And previously we built some machine to detect fraud, especially banking fraud. But it happens that the guys who commit this fraud were arrested, and since then there was not so prevalent case for this model. So
there's very few cases, maybe.
Yeah, definitely.
Too few. And so maybe also the last question regarding this, the training data. I'm quite interested. How did you come up with some kind of training data, or where you had some classified loans maybe, or because was it hand labeled, or
the data originally came from banks, so I don't have 100% information about how they achieve it. Some of them were hand labeled, some of them were like automated, and some of them were based on research of market and the blacklist whitelist solution.
Okay, so cool, thank you. In case you have any more questions to Dominik, please don't hesitate to send him an email or contact him via LinkedIn. So Dominik, again, thank you for joining, and hope to see you soon, maybe in person at some data science conference, and have a nice evening. And we are now joining we are now jumping to the last talk for today. So this will be by Gojko Galonia, Transparency and